All right, we're going to start looking at part two of the geometry exam from August of 2015. And all 7 questions in this part are worth 2 points, so be careful. If you make one mistake, one simple mistake, you're going to lose 1 point out of 2. So just be careful in what you do. All right, it says for number 25, a wooden cube has an edge length of 6 centimeters and a mass of 137.8 grams. Determine the density of the cube to the nearest thousandth, and then state which type of wood the cube is made of using the density table below. So we haven't talked about density in this class too much. Hopefully in science you have talked about it. So here's a little formula I want you to write down. You have density is equal to mass divided by volume. So in this formula, your mass, or I'm sorry, your M stands for the mass, which they actually give you in this problem. And then the V stands for volume, which they actually don't give you, but you have enough information to find. So we're going to need to find the density, but first we need to find the volume. Well, if you remember, we have a cube here. And if you remember from when we talked about volume, the volume of a cube, or a cube in and of itself, has 3 sides that are the same. So if one edge is 6, then all of them are. So our volume is going to be side times side times side, or length times width times height. You can think of it that way, but it's going to be 6 to the third, which is equal to 216. And remember, that's cubic grams. And we don't need to write that right here. So to find density, now we're going to plug this in for V. We're going to plug in our 137.8 for M. So we're going to get D is equal to 137.8 divided by 216. Your D ends up being your density, 0.6379. Says to the nearest thousandth. Remember, there are 3 zeros in 1,000, so 7 is your thousandth place. In order to see where to round that, you look at the 9. Well, the 9 tells the 7 to go up to 8. So our density is equal to 0.638. Now, if you look at our chart to answer part 2, which one does it match? Well, obviously it looks like ash. So ash is the type of wood. All right, looking at number 26, you're asked to construct an equilateral inscribed in circle T shown below and leave all your construction marks. So I want you to write down what an equilateral triangle is. 3 equal sides and 3 60-degree angles. And then hopefully you remember back to what we did. So if you don't have a compass, you can just watch this. What I want to do is measure out the radius of the circle. So I'm going to go ahead and do that. And this is about as close as I'm going to get with this computer program. So what I'm going to do now is go to the edge of the circle. It doesn't matter where you start, but you want to start somewhere, put your tip of your compass, and then go around. Now, we could make the entire circle. I'm not going to go and make the entire circle because then you're going to end up with a whole bunch of circles all around, and I don't want to do that. So I'm just going to make the mark as long as it goes through the circle. Now, the next part is important. What you do is keep the radius of the compass the same. Put your end or your point of the compass on that intersection point, and now we're going to make another mark here. We're going to keep going around the circle until we have all the marks that we need. Almost done. One more. All right, so now we have 6 intersection points. Now you have to connect the lines or use your straight edge. You'll have a straight edge. What you want to do is connect every other intersection point. So you don't want to connect them all to each other. If you were to connect them all to each other, hopefully you understand you'd end up with a hexagon. Right? Remember, six-sided figure, but we don't want that. We actually want an equilateral triangle. So we don't want to connect all the intersection points. We want to skip one. So we're going to connect here. And we're going to connect here. And we're going to connect here. All right, now you have created an equilateral triangle inscribed in a circle. Okay, looking at number 27. Let's read it. It says, to find the distance across a pond from point B to point C, a surveyor drew the diagram below. The measurements he made are indicated on this diagram. So to find the distance across the pond, so from point B to point C, so keep that in mind. All right, it says use these surveyor's information to determine and state the distance from point B to point C to the nearest yard. So we have this. Now, you might look at this first and think, well, I have right triangles, so I can use Pythagorean theorem, a squared plus b squared equals c squared. And you might, in a way, be able to do that if you choose to go that route, but I think that'd be more complicated. I think an easier way is to recognize that we actually have two similar triangles here. We have this triangle, which I'm outlining in red, and then we actually have another triangle, which I'm going to outline, kind of try and do around in blue. These are actually similar to one another. So that means we can set up a proportion if we would like. So we have x, this is what we're looking for right here. And so if I were to draw, let's just say I were to draw these next to one another. So I'm going to draw that first one I did, the red one, and I'm going to kind of rotate it. So this would be the right angle. So try and picture that red one. The bottom is 120. The hypotenuse is 230. And we don't know the backside, but we don't really need to know. We could figure it out, but we don't need that to answer the question. Then we have the blue one, which I actually do in blue here. The bigger one. And what we're actually looking for is x down. Do this in red, looking for x. And we know the hypotenuse. Now the hypotenuse is the entire side. This plus this. So these two plus one another. So that entire side is actually 315, right? Because 230 plus 85, 1, 315. So this side is actually 315. Okay, so now if you recognize that these are similar triangles, you can go from here and set up a proportion. So what you would do is 230 over 315 is equal to 120 over x. And that would give you, when you cross multiply, you get 230x is equal to 120 times 315. 37,800. Then you divide by 230. Divide by 230. You get x is equal to 164.3. It says round to the nearest yard. That means you don't want any decimals. So this would equal 164 yards. Now, if you look at how I set this up, There are other ways you could have set it up. I'm going to show you another way you could have set it up. Instead of doing 230 over 315, this is how a person on the website did it. They actually did 120 over 230. So they used, right? So they did a little bit different proportion. All right, so that's a little bit different. So just another way to do it. Okay, looking at number 28. It says in parallelogram ABCD, shown below, diagonals AC and BD intersect at E. Prove that angles ACD, or angle ACD, is congruent to CAB. All right. So you might get, I'm sure that you're sick of this. If you've been doing this extra credit over and over again, which is good. I'm glad you have. But you've also had to write down the properties of a parallelogram over and over again. You have to do it again. You're not going to be able to do these problems if you don't know these properties. So when you're talking about a parallelogram, you need to start thinking, what is it? So if I'm a parallelogram, I have two sets of parallel sides. I have two sets of congruent sides. My opposite angles are congruent. My consecutive angles are supplementary. And my diagonals form two congruent triangles. That's just a couple things to keep in mind. So I'm going to go to the an answer that I saw that I think is a good one I want you to write down. And here's one way to do it. All right, so look at what this person wrote who did this. So they have their statement. They just wrote the given information and the reason for writing it, just the fact that it's given. Then they wrote DC. So DC is parallel to AB, and DA is parallel to CB. How do you know that? Opposite sides of a parallelogram are parallel. And we just talked about that. And then we proved that ACD is congruent, or angle ACD is congruent to CAB because alternate interior angles formed by parallel lines are congruent. So alternate interior angles. So if I were to extend this line, CD, keep going here, and then AC is extended, CAB is alternate interior with ACD. Those are alternate interior angles. And if you know that these lines are parallel, CD and AB, then this line AC going through, it's going to create alternate interior angles that are congruent. All right? So that is number 28. Right, number 29 says triangles RST and XYZ are drawn below. If RS is equal to 6, ST is equal to 14, XY is equal to 9, and YZ is equal to 21, and angle S is congruent to angle Y, is triangle RST similar to XYZ? So sometimes you know triangles are similar and you can use that to find something. Here you're given information and you have to figure out, are they similar? So here are three ways to prove triangles are similar. First off, AA similarity, which is angle-angle similarity. If two corresponding angles are congruent, then you have triangles being similar. We're only given one angle here, or one pair of angles, and we're not going to be able to find the other ones. You might be thinking, well, maybe I can use trig to find the other angles. We don't know that these are right triangles, so in what we've learned, we couldn't find the other angles here. So we're not going to be able to use AA similarity. Let's go down to SSS, that's side similarity. So three corresponding sides are in proportion. Well, we don't know all the sides. We know two sides for each triangle. So we're not going to be able to use that. Let's go to the middle one, side angle side similarity. That says the two corresponding sides are in proportion and the included angle is congruent. So I'm gonna draw this again. And I'm gonna make it so the triangles are, so I'm gonna draw this ZXY, or what did it say, triangle XYZ. So remember, if you look here, R is corresponding to X. So I'm going to redraw this, okay, and Y is corresponding to S. So it's really, if you were to take this triangle and kind of go like this with it, like rotate it. So I'm going to try and draw it so we have something similar here. So it's kind of like this a little bit, and our X is down here, our Y is here, and our Z is here. All right, so now let's label the sides. You could have done it with the original picture here, but I don't know, having it like this and looking at the corresponding letters is just going to be easier. So RS is 6, ST, I'm going to put that under so we don't think it's an angle. So that's 6, ST is 14, XY is 9, and YZ is 21. So we have the corresponding sides, this one and this one, and then the 6 and the 9. Then it says angle S is congruent to angle Y. So these are corresponding. So we have two sides in the included angle. The included angle means it would be the angle in between the two sides. All right, so we have everything we need if these sides are in proportion. So how can we check that? Well, we can go 9 over 21. Is that equal to 6 over 14? All right, we could do that. Or, I mean, that's not the only way. Or we could say, is 6 over 9 equal to 14 over 21? All right, and actually others we could do, but let's look at these two. Is this true? So we're not saying that it is, we're checking it out. So if you had something like 1/2, is that equal to 4 over 8? You'd say yeah, because 1/2 is, 1 is half of 2 and 4 is half of 8. Also, you can check the cross products. If they're equal, then you have proportional values there. So 8 is equal to 8. Now, if you had a situation where you had maybe 2 over 3, and you wondered, is that equal to 4 out of 8? Well, you should look at that and say, no, that's not true. And one way to check it, cross products. Is 8 equal to 12? No. So those would not be similar triangles. In this case, we're going to do the same thing. Because it might not be obvious, especially in this one, it might not be obvious if those are equal or not. So let's just multiply our cross products, or get the cross products. So 9 times 14, so 9 times 10 is 90, 9 times 4 is 36, so that looks like that's going to be 126. 21 times 6 is also 126. So that checks out. If I did it over here, it'd be the same thing. 126 is equal to 126. That means that these triangles are, in fact, similar. Now I'm going to just show you what I found on the website, if it was any different. Yeah, they just wrote this down. And they actually wrote SAS, so you might actually want to write that similar by SAS. All right? So that's it for this video. I'll go through some other problems, starting with number 30 on the next video.